All right. So we're going to go ahead and talk about absolute deviation word problems. We're also going to talk about graphing absolute value functions. Just like the last take, everyone want to say hi, YouTube?
Hi, YouTube.
All right, wonderful. All right, here we go. So here is the formula for absolute deviation. So I'm going to go ahead and pitch this with this idea. This is a marker. I am a marker manufacturer. All right, that's what I do. All right. Now these markers are just made from a mold. Okay. And, we put them through the machine and we take them out and we check to see if it's up to the standard that we're looking for. So these markers, I'm looking for them to be 6 inches in length. Exactly. 6 inches. Although, does the mold put out 6 inch every single time? Or could there maybe be some defects, right? Yeah. Maybe some defects. So 6 inches is what I'm looking for them to be. That is the given value. So when we plug this into the formula, it's going to be absolute value of x minus that given value of 6 inches is equal to, now here's the thing, like we said, there can be some malfunctions, okay, or misprints, as you will. If it, prints out and there's a big inch sticking off the end here, it's 7 inches, that's absurd. I'm not going to, I have a certain level of perfection for my markers, okay? So mine can be off by 0.05 inches. And at that point, anything within that range, it's acceptable. Anything higher than that, more off in either direction, short or long, we're throwing them back into the melter and using it for materials, make another one. Okay, get the idea? So, given value right here, how much we can vary right here. So, what does this look like? Does this look like something we've been solving? Say it again?
All the numbers equations.
Absolute value, yeah, very good. Okay, absolute value equations, right? So we can go ahead and solve this, right? Are the absolute value bars currently isolated? Mm-hmm. Yeah, right? So what do we do to get x by itself? What's the word? Bifurcate. We're going to bifurcate here, right? So let's go ahead and bifurcate. Yeah, we're going to do some bifurcation, right? So we're saying what's inside the absolute value bars, x minus 6, could equal
0.05.
0.05, or
X minus 6, negative 0.05.
Negative 0.05. And this is going to lead you to your two different solutions. Well, we'll talk about what that means in a second. So right here, what are we going to do to both sides?
Add 6.
Add 6, add 6. That's not lined up right. Add 6, add 6. Okay. What do we get?
X equals to 6.05.
6.05. Oh dear, that is not right. 6.05. Okay, and?
5.95.
And 5.95. So what have we just found? I have two numbers here. Is this the two exact values I'm looking for the marker to be? What exactly is this? Go ahead, Kason.
The number, what it can be in between.
Oh, good. Okay. The numbers. So we're looking for. So this is like a range, right? So there's two ways we can show our answer, and that is dependent upon what the question's asking. Ready? Either it's asking us for the minimum and maximum value. So the minimum would be 5.95 inches. This would be the min. Or, and this would be the max. Alternatively, if it asks for all possible values that I'd be accepting of the marker, we would say x is in between and including 5.95 inches and 6.05 inches. So it depends what the question is asking. Is it asking for all the possible values, or is it asking for the minimum and maximum? That's what you're going to be on the lookout for. But in terms of what you actually have to do here, given value, so x, the absolute value of x minus the given value, what we're looking for it to be, equals to the amount it could vary in either direction. Now, is there an easier way we could have just done this in our head?
Yeah. Mm-hmm.
How so? Without the whole algebra, what would you?
Add 0.05 minus 0.05.
Yeah, we would just take 6 and add this on, and we'd subtract it off, right? So I'm still looking for you to show me algebraically and prove it. This is the formula that does that. But you can also just do a quick mental check. Is this number 0.05 less? Is this 0.05 more? That's fine. But I am looking for you to do it algebraically. So what I want you to try now is on page 23? Yeah, in the margin. So there's some handwriting. See that problem? Tiago's going to have a little bit of trouble doing this problem because he has a lot of doodles. But you're going to go ahead and do page 23. On the left margin, there's a problem about handrails. I want you to go ahead and solve that problem. I'm going to pause the video, and we're going to come back. Okay, so can somebody tell me, just looking for two things. I just want the starting formula with numbers filled in, and then our result as well. Yeah, go ahead. There you go. Absolute value of.
X minus 42
Yep.
is equal to 3.
Oh, did you say 3? Cool. So yeah, this is our starting, equation, and then from there, what do we get as our answers? Go ahead.
X minus 42 equals 3, and then X minus
Just give me the answers.
Oh, the minimum is 39 and maximum is 45
Good. 39 inches.
inches.
You got it. And then the max is 45 inches. So again, take note: is it asking for the min and max, like it was in this case, or is it asking for all the range of possible values? This seems like a big difference for a handrail. Don't you agree? Like that's took me 6 inches of difference. They'd be like, yeah, that's fine. I feel like it's a company that's just like, yeah, whatever. We just put up handrails. They don't have to look good. Interesting. Anyway, that's it. That is absolute deviation word problems. We feel like kind of okay. Even if you don't fully grasp it yet, that's like go study it once. We should be okay. But feel free to let me know. Feel free to let me know if you need more help with that one. Here we go. Let's get into the beef of the lesson.
He doesn't want me to.
Sorry for those who don't eat beef, but we're doing the meat of the problem. Here we go. Page 27. That's what I'm saying. I'm sorry. We're getting there anyway.
What if it's chicken?
Today is not a vegetarian-friendly lesson. All right, here we go. Page 27. Page 27. So let me tell you, graphing absolute value functions is done completely differently than solving absolute value equations. So if you remember, here was absolute value equation. How many variables were there here? 1, right? So we can solve for that variable, which is what we did, and we got like 2 answers typically, right? Here, how many different variables are there? 2, right? So there's going to be a set of values, right? An x and a y paired together, making a n order pair or coordinate point. Good, right? So that's what we're going to be doing. We're going to get a set of them. We're going to graph something. So this is the parent function. Let me write that. Let me write that in the marker. This is the parent function for exponential functions. It is the most basic of absolute value functions. Y is equal to the absolute value of x. So let me write that down here. Parent function. Okay, cool. So let's go ahead and put some values in. It gives us some 5x values already. -2. What's the absolute value of -2?
2.
I agree. Absolute value of -1?
1.
Absolute value of 0?
0.
Absolute value of 1?
1.
Absolute value of 2?
2.
Oh, okay, cool. What do we notice about these y values that we got?
They're all positive?
They are all positive. Good point, right? The absolute value of something is always positive, and there's nothing else being done to the the result. It's just going to result positive here. Yeah.
They decrease, and at some point, in this case 0, it will start increasing.
Cool. So yeah, it kind of decreased and it came back up, right? Somebody pointed out last class, very appropriate of today. It's a palindrome,
Oh!
right? And what's today?
A palindrome.
Today's the last palindrome of the year. 12, 22, 21.
Yeah.
Cool. Anyway, this actually almost even says that. It doesn't though. All right, so let's go ahead and graph it. Let's see what we get. Anybody have an idea of the shape we're going to get here?
Parabola.
Not a curve, not a parabola.
This?
Sure. A V.
It's like symmetrical. It's a
Like
symmetrical line.
VV. V for absolute value.
It's
Let's
a
go ahead and graph it.
It's a symmetrical.
0, 0, 1, 1, 2, 2, and we'll go in the other direction, -1, 1, -2, 2. So here it is. We have ourselves a V. Okay. Say again? So let's talk domain and range here real quick. I want everybody to think in their head, what is the domain of this function, all the possible x values? Turn to your neighbor, try to figure it out together. Domain, all the x values, yep.
I got that.
You said 0.
Can I say that?
Yeah, go for it. Okay, what is the domain?
All real numbers.
The domain. The domain is all real numbers, right? Was there any restriction on what we plugged in for x? No, we can plug in whatever we wanted, right? We can plug in 50, and we're going to get what? 50. So it'd be something up here. Well, that's pretty good, actually. Wow, that's pretty good. Actually, no, next question. The range. What are all the possible y values? Turn and talk to your neighbor, try to figure it out together.
Anything positive.
If you're saying all real numbers, you're wrong. Try again.
Greater than or equal to 0.
Positive number Greater than 0.
3, 2, 1. What is the range?
All real numbers greater than or equal to 0.
Okay, cool. So what we would say probably is y is greater than or equal to 0, right? We hit 0 and everything higher than it could be. Yeah, but you're right. Yeah, all real numbers that are greater than 0 or equal to. All right, let's go ahead and look at this second one. So looking at this, does anybody have any ideas about what's going to happen to our parent function when we have this -5 out here on the outside? So if here's my, actually I guess this would be it, right? There you go. If this is like my absolute or my parent function, what would we guess might change about it? What would it might do? So you're thinking maybe down by, are you guessing 5? So we're thinking maybe down by 5. Does anybody have any other guesses? Ideas? Maybe left or right? Okay, so we're thinking down 5. Let's give it a shot. All right, let's give it a shot. So let's try -2 first. The absolute value of -2 minus 5, -3. Absolute value of -1 is 1 minus 5, -4. 0 minus 5, -5. The absolute, let's pick something else. What is the absolute value of 1?
1.
Let's try this again. Absolute value of 1? Minus 5? -4. Oh, hey, look, we're repeating here. And the absolute value of -3. Oh, sorry, no. 2. Minus 5. -3. All right, cool. So, let's go ahead and graph this, and then we'll talk about it in a second. So let's go ahead and graph it.
It's going to go down.
The answer is no before. It will still be no when you ask again.
What if I go to the subscribe part?
So, it seems like our prediction was correct. Our whole entire parent function moved down by 5, but it kept its same shape, right? It didn't like get skinnier or wider. Does everybody know what this point is right here that they reflect over? Like they're kind of like reflecting over this. What is that?
Vertex.
Good job. The person sitting there last class got it as well. That must just be the seat. Is there something written on that desk? Just kidding. Here you go. Grab yourself a
Who's
sticker.
that there? Yay!
Nice catch. All right. So this is the vertex, everyone. This is the vertex. It is also located, ready? Or should be at least, in the middle of your table. Okay. It should also be located in the middle of your table. Now, here's our graph. This looks good. Let's keep going. Let's check this one out. This is number 4. And did it use the points just like the other one was -2, -1, 0, 1, 2? Did it do that for this 4th one? Look on the paper. No, right? It uses 3, 4, 5, 6, 7. Now here's the issue. If we had tried, again, it gave you these. But let's just say we used -2, -1, 0, 1, 2, because we didn't know any better. We just came off those last ones, and it seems like the vertex is always at 0. Let's see what happens if we do this. Let's plug these 5 numbers in. So -2, Avi, can you help me with these? -2 minus 5? -7, so absolute value is 7. -1 minus 5? -6, so absolute value is 6. -5 is absolute value is 5. 1 minus 5 is -4, so absolute value is 4. Which gets us 3. Let's graph this real quick.
Wait, are we supposed to do this with you?
You're welcome to do it on your paper. It doesn't hurt. Go, you graph these two. But -2, 1, 2, 3, 4, 5, 6, 7. -1, 6, 0, 5, 1, 4, 2, 3. Do we have a V shape here?
No.
No. If you didn't know any better on a quiz or test, you might go like this, and you get it wrong, because it would look like this is a linear equation. However, that is not how absolute value functions work. What we need is that vertex. So if we kept going, maybe we'd find it. This is the 5 that they suggested on the paper that were already there for you. Let's give these a shot. So I would keep it going. 3 minus 5, which will be 2 when we take the absolute value. 4 minus 5, so 1. 5 minus 5, 6 minus 5, so that's going to just bring us 1. And 7 minus 5, 2, which will absolute value is 2. Let's go ahead and try it out. I think we found it. 3, 2, 4, 1, 5, 0, 6, 1. Here we go. We bounce back. And 7, 2. Move out of the way so you can see over there. So there is where our V actually occurs. So do you see the flaw or the issue if you just try to use -2, -1, 0, 1, 2? And how this could take a really long time that we'd rather not have to do. Does everybody see that? There is a method that we use to find this point is the vertex.
Method to the madness.
There's a method to the madness, yes. So we need to go ahead and find the vertex. Let me see. Do I want to tell you how to find the vertex before or after this problem?
Before.
Yeah, let's find the vertex first.
Divided into.
Uh,
Oh, you wouldn't divide it up.
yeah, okay. So the question is, hey, is there an easier way, a more effective way to do this problem?
Bro.
And it is, I know, you're like, oh my gosh. Yeah, this, trust me, you're going to like it. You just have to know first. What's the matter? You don't trust me?
Not really.
Okay. Well, anyway, it's on top of page 28. Let's talk about finding the vertex first, and then we're going to graph this one. Then I'm going to show you an even more efficient way to do it, and you're going to love it. Trust me. There again with that keyword, trust. All right, here we go. We're going to find the vertex of each of these right here. This is called vertex form. This is called vertex form for absolute value functions. So we have y is equal to a times the absolute value of x minus h plus k. And the vertex, let me do this in a different color. The vertex is found as h comma k. So we're going to try a couple of these out, and I'm hoping it's going to become a little clear to you. Here's the first one. The parent function. What is being added, or I guess subtracted, from x right here? If there's nothing written. 0, right? It's like x minus 0 on the inside. And then on the outside? Nothing. So it's 0 again. Does that make sense? Was the parent function's vertex 0, 0?
Yes.
Okay, cool. That's what we were expecting. So cool. The vertex for the first one is 0, 0. How about over? Yeah, how about over here for number 2? What's the h value? Go ahead.
-4.
Let's see. -4, and then what's on the outside?
0.
0. Okay, cool. So yeah, this looks like a -4, right?
Isn't it supposed to be 4?
I heard somebody just say it looks like 4. Why? What did you say that?
Because in the equation it's negative, so h is just h is not negative.
So just like point slope
Yeah.
form, right? Just like point slope form, there's that minus sign or the negative sign in the formula. So in order for this to have stayed negative, the k or the h value must have just been a positive 4. Okay, so yes, actually, the x switches, the y value will stay the same. We haven't gotten to it. Let's try this one. What would the vertex be for this one? Good.
Negative.
-3, 0. Very good. This switches. Let's go ahead and talk about number 4. And then I'll give you a funny analogy that, my pathetic analogies. Go ahead. -1, -2. Once again, the x stays the same. The y swap. Oh, sorry. No, I switched that. The x value, or h in this case, switches. The y value stays the same. Okay. Are you ready for my, like the k? It's the y value of the vertex. Here's my analogy. Ready? When you have a boyfriend or girlfriend, right? And then you break up with them, they become your what? They become your ex, right?
You can say what?
No.
W.
No. When you so when you have a boyfriend or girlfriend, you break up, you become your ex. Now, unfortunately, sometimes people have some bad breakups, right? And you might go around school and you might tell your friends, you say, "Don't listen to my ex. They're a liar." When we come over here and we find the vertex, the x is lying, the sign is different, the y they're fine. The y is telling the truth.
What's a k?
H and k are the variables that represent the x and y value of the vertex.
So what is y then?
Y is just a.
When I say x and y, check it out. When I say x and y, I'm referring to the x value of the vertex and the y value of the vertex.
Oh, okay. That's
So
gonna be
yeah,
the analogy.
does that make sense? So I'm not referring to like x and y in the formula.
No, I think there's gonna be an analogy to that.
I mean the instance when we're referring to like the vertex. So when you're trying to remember x, lying, switch the sign.
X.
Y, you can just keep it as it is.
X is the X.
Not a joke.
What?
Maybe I missed something, but what's the A doing that?
Well, good question. So we'll get to A in just a moment. Okay, we'll get to A in just a moment. Is that what your question was as well? It's a great question. We'll get to it right now. So let's go ahead and come back to this problem. Let's come back to this problem. We're gonna start by graphing this with a table, and then we're gonna show you that super efficient method. Here we are. Let's start by finding the vertex. I know it's already found for you, but I like to write it right underneath so we just drop things down. What is the vertex here?
5. -5.
negative 5, comma 0, right? The x changes, and y is 0 here. Doesn't have to worry about saying the same, but it would. So this is going to go right in the middle of our table. From there, we're going to plug in 2 points either above or 2 points below. Okay, so that's why we made up the rest of our table. So let me graph that first. Negative 1, 2, 3, 4, 5, 0. And that was 0. Let's go ahead and plug in some more values. Negative 6, let's see. Negative 6 plus 5. Negative 1, absolute value of negative 1. 1 times 2? 2, cool. Negative 7 plus 5. Negative 2, absolute value of negative 2. Times 2? 4, awesome. Do we need to even plug these two in? No, we know that this reflects over, right? So you could plug them in, or you could just go like this. Right? Pick the two that you feel like are easier to plug in. Reflect the last two over. Thank you for that yawn on my YouTube channel. It's perfect. Shows how much my students love my class. All right. Here we go. Ready? Negative 6, 2. Negative 3, 4. We'll do the same thing over here. Oops, that's not the right spot. Oh my goodness. I should try just actually counting. Right? And we can go ahead and connect. I'm looking for us to have 5 points. So the vertex and 2 on each side. So this is our process, right? Find that vertex, plug into your table, and then extend your table 2 in each direction. Luckily enough, we only have to plug in 2 and then flip it over. Any questions on this before I show you the super efficient other method?
Oh my gosh.
What are you saying? Oh no, efficiency.
Is it an analogy?
No, it's not an analogy. It's another method.
Oh.
Here it is. This is just up here. It's not on your packet.
No.
So here we go. What do we always have to start with finding?
What?
The vertex.
Thank you. I was going to say, well, you're letting me down. All right. Let's start by finding the vertex. Who wants to tell me what the vertex is? Once again, I like to write it right underneath so we kind of just drop things right down. Good.
2, 1.
2, positive 2, and 1. Very good.
Oh, 'cause
The x change.
does not lie.
The x change, the x lied, y hold it true. So we're going to go ahead and start by graphing that. Now remember, even if you're making a table, you start with the vertex, put it in the middle, and then extend from there. Here, now we're going to go ahead and use that a value. I kind of like to refer to my a value as my fake slope. Fake slope. And what we do is we count. Well, first off, is this going to be opening up or opening down? If it's positive. Up, okay? It's going to be a V. So we're going to be counting up 4. This is like 4 over 1. We're going to count up 4, 1, 2, 3, 4, and go over to the right 1. Now the reason it's not a fake slope, or the reason it is a fake slope, is because we can also do negative 4, negative 1, right? Down 4 to left 1. But that would make a linear equation, right? Yeah. That's not what we're graphing here. We're graphing V's. So you're going to go up 4 to the right 1. You're going to go up 4 into the left 1. Now let's do it again. Up 4 over 1. That was over 2. Up 4 over 1, up 4 over 1. And look at that. We are done. Is that a little easier than filling in a table?
Yeah.
Yes.
So, your method,
Wow.
right? Let me just repeat it real quick. Find the vertex, plot it. You're either going up or down. You're going to go up 4 over 1, up 4 over 1, up 4 over 1, up 4 over 1. That's it.
Nice.
Simple enough?
Yes.
Cool. Look around. There are still going to be some people who accidentally, in the rush of the test, there's a lot going on, and you're going to accidentally graph the slope, and then you're going to reflect the slope, and you're going to give me a line on the quiz. Be careful. Just know that it does happen. Sure, don't point. Put your fingers down. You meanies. So, don't let that happen, right? It does happen, right? I'm giving you the warning that sometimes that does happen. Try to identify that as a possibility. Use the fake slope, not the real slope. What I would like you to do, these are the last 2 problems. It is on page 30B. B for bedtime. B for bedtime.
Wait, W still going on?
You want to know why there are B pages? Because those are added pages after the fact. And if I had added in and make this one 31, then that means I have to change every single page after that. You know? So this makes it so I keep page numbers on, plans and things like that. The same. So you can go ahead and work on these 2. I'm going to pause the video so you can just see the result in a second. See you soon. And we're back. Take a look at the answers. I don't have much more to say. I think I have one more slide. Let's check it out. No, okay. Point being, positive A value. We are, gentlemen. Positive A value means we're rising up. We're going up and over in each direction. Negative A value, we're going down and over in each direction. Last 2 reminders. is that regardless of whether you are using that efficient shortcut or if you are using the table method, number one step has to be finding the vertex, right? Because you don't want to start a table just with random values because you might completely miss the vertex and not get a V. So you need to find the vertex. For number 2, remember that A is your fake slope, not your true slope. So you can avoid making a line by accident. But that's it. Everyone, what do you have to say?
Like the video and subscribe.
Thanks, YouTube.